Greetings, this is Artie from Artifact Electronics. Last weekend I found a local seller that claimed to have a bunch of surplus electronics from a local university, and of course I headed over. There was a mountain of rack mount servers and all sorts of assorted stuff in there, but the first thing that caught my eye was this HP Agilent 6611C DC power supply that'll supply up to 8 volts at 5 amps. We plugged it in and it powered up, even though it seemed that it took a little longer to boot than these usually do. But once it was up, I proceeded to enter a voltage to check it if it could hold a voltage, and it promptly reset. And after a while it became clear to me that this thing was stuck in a cycle where you turned it on, it did kind of a slow boot, and then anywhere between 10 to 15 seconds later it would reset. So that went into my pile. Next we had this VectorViz monitor ISO VAC2 model WP30, which I looked it up on my phone, and essentially it's a Variac with an isolation transformer and some overcurrent protection circuitry in there. It's kind of a heavy unit. I wanted to plug it in, but the seller basically said, look, just assume that it doesn't work and give me whatever. And so we came to a mutual agreeable price, and especially since I don't have an isolation transformer, it seemed like a good deal. Finally, I stopped by a thrift store, and there wasn't anything interesting except this Kilowatt energy monitor, and I think it was like $1. I plugged it in at the store and it didn't do anything. So with all of that in the car, I figured, okay, I got some fodder for good repair videos, but things didn't quite turn out the way that I expected them to. I'm going to look at the 6611C first, especially since I did a repair on the 6612C a few episodes back, so I do have some of the procedures down, even though the problem here is completely different. Now when I got it, it had the word bad written across the back in large letters with an indelible pen, and that just, for some reason, that just bothered me to no end, because there were no other stickers on here, no inventory tags, nothing. So I proceeded to use some isopropyl alcohol and paper towels, and after a little while and some elbow grease later, it was gone. And sometimes doing mindless things like that awakens repair inspiration in me. So what I came up with, it's resetting. My first thought was that the processor is resetting, but there's also a good chance that the supply was shutting itself down and restarting, which I could test and essentially look at the 5-volt line and see if it dips during the time that it's resetting. And so the first thing to do, though, is to take it apart and look at the more obvious things. Off came the case, and it looks identical to the 6612C inside. All of the fuses are in the same locations. I'm not going to show them specifically because you can reference my previous episode for those. And I tested all of the fuses that were accessible in this state, and they were all good. I then loosened and removed the digital board, and even though I've seen it before, I was kind of hoping for a large RC reset circuit somewhere, but no such luck. And I checked, there is the main output fuse over down here. There was a problem with the last unit, and I checked that one, but no luck, it was good. So basically what I had to do was put it back together, power it up, and and stare at it with a scope and see if the power line dipped, and if it did, do some analysis on the power supply itself. So for now, let's put it back together again, and well, not all back together, but let's put it in a state where we can power it up and do some further research. The digital board is back in its place, and let's see what it does. So I'm sitting here counting and waiting for it to reset. See if there's anything weird happening when it resets. But it looks like we already passed the reset time. It's not resetting anymore. And to tell you the truth, the reason I didn't show it to you in its reset mode previously was because I went through this exercise to open it up and reseat things. I didn't even measure fuses. I just kind of reseated things and flexed connectors. It stopped resetting. So here it is. So let's see if we can set a voltage, and if that voltage is actually output. And put the meter here. So let's go in and set the voltage of enter number 5.25 volts and a current of 500 mils. Oh, it's already set at something, but we can set that at 500 mils, and let's enable the output. And it's outputting pretty close to 5.25. Needs a bit of calibration, but let's see what our multimeter has to say. And the multimeter says 5.249. Same thing. So it is outputting a voltage. I need to put a load on it, but it hasn't reset yet, and it seems to be working. So just for grins, let's try another voltage. Let's set it at the maximum rated voltage. Oh, max. Let's see what it says if we exceed the maximum rated voltage. It says out of range. Alright, so voltage, enter number 8. And it reads 8 volts. So this seems to work. As I said, it needs a load. Now, I really don't like repairs like this because it's not really a repair, and the problem might rear its ugly head again. But maybe this got fixed because I cleaned off the words bad from the top of the cabinet, and that way it forgot it had to not work. Anyway, it seems to work. What I'm going to do is put a load on it and let it soak overnight, and then check voltages in the morning and see if it is in fact fixed. If something got kinked in there, I have no idea. But I got a working 6611C. Well, tomorrow morning I'll know if I got a working 6611C, but this was obviously a successful purchase and a nice addition to the bench. Here's the WP30 that the seller wouldn't even let me test, just get it out of here. So let's see, I got the voltage turned all the way down. The current is basically set, it's a 5 amp device, so somewhere in this range it's looking at probably outputting an amp before shutting down. And we turn it on, and not only does it turn on, but we can set a voltage on the analog meter, and let's see how true that is. It's showing us, the meter says, well, let's put it on 120. The meter says 120, and the analog meter, and the fluke says 118. So it looks like it is working. So, bit of a bust here in terms of doing another repair. But let's at least have a peek inside and see what it is. I mean, the reason I'm happy I got this and it's working is I always, in previous episodes, preached about electronic safety when repairing stuff. But I didn't even have an isolation transformer in my arsenal. So I feel a lot better now that I do have it, and especially one that'll go up to 5 amps, which means that everything else that I fix from now on is going to be plugged into here rather than directly into the wall. Well, let's see what awaits us on the inside of this beast. So, here is a rather massive isolation transformer. The AC comes in, goes straight through this. Here's the auto transformer or variac that is directly connected to the shaft for the voltage adjustment outside. This thing was a little bit squeaky, probably for sitting there for a long time. But a little bit of, I actually used some contact cleaner, sprayed into strategically well-placed areas, and the squeak disappeared. So it is nice and quiet, and moves smoothly too. And then of course we got the array of front-end stuff that provides the switches, the analog meters, and current limiting. Now, the one thing I found was that the current meter was a little low, but I could not, I don't have any documentation for this. There are 3 pots, here, here, and here, and of course marking their current position and then turning them all slightly did not let me change the sensitivity of the ammeter. So I'm just going to have to wait until a manual for this turns up. Other than that, that's about it. This was built in the early 80s, and it looks like it's built with really good quality. 2 down, 1 to go. So now we're going to look at the Kilowatt, which is obviously wordplay on kilowatt. So what this is, it's a power consumption monitoring device for home appliances. Essentially, it's It's an AC voltmeter and ammeter, selectable with these two buttons. And what it'll do is it'll calculate power consumption of your device over time. And if you look up on your power bill how much the power company is charging you per kilowatt, you enter that number in here, and it'll keep a running tally of how much it's costing you to run a home appliance. And that function in itself is not very useful to me for my lab bench. What is very useful, though, is the volt ammeter functions, especially since the ammeter on the WP30 is inaccurate, and I don't know how to adjust it. And even if you do, in this age of digital displays, it's just not good enough to have an to have to rely on an analog display, coupled with eyes getting old and not seeing things correctly. So, and it plugs nicely in to the right side AC plug on it. So my thoughts are, if I can get this fixed, it will show me. It'll show me the digital representation of the current output of this. I did plug it in, gave it some power, and it's just dead. Now I have a pretty good idea what this may be, but let's have a look inside. I've seen some of these before, and they have a large thermal fuse in there that is mounted around the power plug. And what happens a lot is when people got these plugged into an appliance that draws good amounts of power, the inside of the case will heat up tremendously. And when that happens, eventually the fuse will reach its terminal temperature, and it'll blow. It's a non-resettable. A thermal fuse is non-resettable, so when it blows, it blows. There's no power going into it anymore, and it just dies. So let's have a look inside. So I opened it up, and I was right. I didn't want to bore you with the details, but here's the thermal fuse, and it was open. So just for grins, what I did before going ahead and getting a replacement fuse, what I did was I bypassed the fuse, which is okay if you don't have anything, if it is plugged into power, but there's nothing plugged into it, there's going to be very little current flowing, unless, of course, you have a dead short in the processor somewhere, but I just made the assumption that that wasn't true, shorted the fuse, and plugged it into power, and the unit came right up. So I went out and got myself a replacement fuse. It's rated for 99 degrees Celsius and 15 amps, whichever comes first. And as mentioned before, it's non-resettable. It's like a glass fuse. When it blows, it's gone. Now this was originally soldered into the board, and that's an interesting proposal because keep in mind it's a thermal fuse. And what does that mean? That means if its rated threshold temperature is hit, it will blow. So what does that mean? You're going to solder this thing, you're going to hit 99 degrees Celsius easy, especially because the pads are kind of large, you can't really see them, and it's going to take some heat to get this soldered into place. And I was wondering when I opened it, the original kind of looked like this. It was mounted way off board, and it kind of made sense because I guess the longer the leads are, the less heat will transfer from the solder joint to the fuse itself, minimizing or eliminating the possibility of blowing it while installing it. However, I think that at a factory they probably have special jigs that attach heat sinks to the fuse itself, with water or whatever attached to a heat sink, so that when it's getting soldered, the heat up here never reaches 99 degrees. I experimented around with some weird-looking contraptions, putting metal clips on here and attaching a heat sink to this with the metal clips and putting pieces of ice in there, and that just, I don't know, that just didn't look like, I didn't want to go ahead and keep blowing these fuses while soldering them. So what I did was I cut the old fuse off at the fuse end, so the leads were still sticking up, formed the remaining leads into loops, then took a new fuse and formed the ends of the leads into loops, and basically screwed it all together with nuts and bolts. So what that did was I knew I wasn't going to blow the fuse, and second of all, if for some reason there's another problem in here and it starts blowing fuses again, it's going to be very easy for me to replace the fuse. Now I've shored up things a little bit with some hot glue so the nuts and bolts don't loosen, and also there's a resistive bar here, and this side connection was getting a little close to it, so another dollop of hot glue is going to go a long way towards preventing any sort of arcing happening here. All right, let's close her up again. I was especially careful to try to maintain the profile of the old fuse so it wouldn't hit up against anything in the case when I put it back. And if I did that properly, it should go back together easy. So it's back together. It actually fits here without really obscuring anything other than the very lowest range of the ammeter. You can still read it from the side, but since the purpose of this is to replace the ammeter, I think we're good. So what I've done is, well, let's turn it on first and see it come to life. And there you go, measuring voltage at 116.8, which kind of jives with the measurement we made earlier with the fluke meter, except I changed the voltage adjustment, so I think it's working. And now we can get to the ammeter by pressing the second button, and it basically tells us it's consuming nothing. What I've done is I hooked up a floor lamp to this that has 3 CFL bulbs in it that I can individually turn on and off. The CFL bulb specifies that they use 300 milliamps, but that's probably not regular operating current. That probably keeps inrush in mind. So it should be somewhat lower than that, but probably above 200 milliamps. So we can go ahead and turn them on one by one. So here's the first one. And the first one consumes 210 milliamps. We then hit the next one, and that one consumes about 230 milliamps. And then the last one consumes 230 milliamps. Now, that's all cumulative. I could go to them one by one, but here you go. We now have one thing I noticed though, it's a little bit, the update rate's a bit slow on it. So if I turn this off, it does take a while for it to update the current draw. So whenever doing an initial test on a piece of equipment, as you're turning up the voltage to see when you hit if there's something wrong with it and it's going to consume a lot of current, it's probably a good idea to watch the analog meter. Not so much for accurate reading, but it gives you an immediate response, and you can see if you see it deflect radically, you can turn things off quickly. Whereas if you're going to wait for this to update and there's a lot of current flowing through a piece of equipment, you may do some damage. So actually these two will work very well together. Now I was thinking about something I said earlier, which was probably false, and that is pertaining to the fuse, or the reason for it to blow. I mean, it is true that the fuse will blow at 99 degrees Celsius or 15 amps. However, I don't think that the reason this fuse blew was because we reached 99 degrees, but rather because we put in, or or that had been put in more than 15 amps of current. Because if this is a plastic case, if this reaches 99 degrees, the case is going to, it's definitely going to show signs of that kind of temperature. So I think I can say with 100% certainty that the reason the fuse blew was because the appliance connected to it drew more than 15 amps. Now it's interesting to note the way the thermal fuse works. It's two contacts held together with a small plastic ball. And the characteristics of the plastic ball are that if it reaches 99 degrees, it will melt, dissolve, and release the contacts and open up the fuse. And that can be one of two things. If the ambient temperature around it reaches 99 degrees, it will open up. Or if the current flow through the contacts heats up the contacts to that temperature, it will also melt and blow the fuse. So there's my correction. Now I really like the idea of having a digital display for the ammeter, and since it turns out I have a second Kilowatt that I purchased last year for doing some work around the house, especially since I'm not too fond of sticking test leads into AC outlets, so we can use that one as a digital voltmeter. So turning it on and kicking this one into ammeter mode, we now have easily removable digital displays, and that gives us the best of both worlds because we can get accurate measurements out of the kilowatts. They do update a bit slowly, especially the ammeter part, but we do have the analog meters right next to them, and we can see trends very quickly, i.e. if we go past a certain voltage and the current consumption increases radically, we can immediately turn back the voltage to save whatever there is left to save in the equipment under test. So with that, we're nearing the end of the episode. To sum things up, I got 3 items that supposedly needed repair. But as you saw, the HP 6611C, even though it looks like it did get repaired, I don't know how I repaired it. So that's a bit unsatisfying, and I won't be able to give it a clean bill of health until I run this thing overnight, soak test it overnight with a load on it, and see if things work, if the current protection works on it. But at this point it looks good. I think that one has become functional again. Second part was the WP30, which of course didn't need any repair. It just worked. And the only thing I did there was spray it with a little bit of contact cleaner used as a lubricator for the auto transformer. And maybe I'll run across the manual for this sometime, and at which point I'll go in and see if I can adjust the meters to be more accurate and do a comprehensive test of the overload detection. And last but not least, the Kilowatt, which had a bad fuse, that got replaced, and that got replaced in a way so as not to blow the fuse while installing it. And that wraps up everything. Hope you enjoyed it. Hope you learned something. And if you think it's worth a thumbs up, then don't be shy about clicking the thumbs up. And to make sure that you don't miss any future exciting episodes, go ahead and subscribe if you haven't already. Thanks.